In the last class, we were discussing about in-situ density of sand by sand replacement method. So we will continue with that. So I'm sharing the screen. I hope it is visible to you. For determination of in-situ density, determination of water contents of soil collected from the hole. So the first step is weight of empty container. Here we are denoting with W5. Initially, weight of empty container we noted by W1, but because already we have given the name as W1, W2, W3, and W4. So now for weight of empty container, we estimate to be W5. Next, weight of container plus wet soil. This is taken as W6 gram. Next, weight of container plus dry soil. It is known as W7 gram. Next, water content W is equal to W6 minus W7 divided by W7 minus W5. So the dry density of sine rho d comes out to be rho t divided by 1 plus W in gram per centimeter cube. So what are the pre-viva questions? What is the objective of sand replacement method in order to determine the in-situ density of soil? This is your objective. So what is the relationship that can establish between the dry density with known moisture content? This is the relation. Rho T equal to W divided by VH. It is equal to W by WS into rho S. Now, what are the apparatus that are needed in this test? Apparatus already we have seen. So the apparatus includes what you can see. Just going back, the apparatus is sand pouring cylinder, cylindrical calibrating container, glass plate, tools, metal container, metal tray, weighing balance, moisture content cans, glass plate, oven, and desiccators. What is the significance of determining the in-situ density of soil? In-situ density of soil is very important parameter in order to know the bearing capacity of soil and stabilization properties. So what is the results? Weight of wet soil from the hole is a W gram. Water content of the soil W percentage. Weight of sand that fills the hole is in gram. Volume of hole VH equal to WS by rho S. Bulk density of the soil rho T is equal to W by Vs. Dry density rho D equal to rho T divided by 1 plus W. Dry density of soil is in gram per centimeter cube. Water content of the soil you need to calculate. Now verification and validation. Sand replacement method is an indirect method of finding the density of soil. The basic principle is to measure the in-situ volume of hole from which the material was excavated from the weight of sand with known density filling into the hole. The in-situ density of material is given by the weight and excavated material divided by the in-situ volume. The dry density of most soil varies from 1.1 to 1.6 gram per centimeter cube. In sandy soil, the dry density can be as high as 1.6 gram per centimeter cube. In clay soils and aggregate loams, it can be as low as 1.1 gram per centimeter. So what is the conclusion? The dry density of the soil is this much gram per cc. Comparing with the in-situ density by core cutter method, more or less the same value is achieved. So this type of soil is silty clay. So what are the post viva questions? Why we need to determine the unit weight of sand to determine the unit weight of soil? Because it is important. Which method is the accurate one? Core cutter method or sand replacement method? As per my knowledge, I will go about core cutter method. How many samples are to be collected and why? How many 3 samples are collected? What is the advantage of sand replacement method over core cutter method? It is simple and easy. What is the practical application of this test? To know the bearing capacity of soil, the soil needs to be tested for in-situ density. Next experiment is determination of particle size distribution by sieving grain size. So what about this? It is spending 16 minutes in application. Okay. So next experiment is sieve analysis. I am sharing the screen. I hope it is visible to you. Determination of particle size distribution by sieving grain size analysis. To determine the particle size distribution by sieving grain size analysis and to determine the finest boundaries effective size again from the equation. What is the aim of this experiment? To determine the particle size distribution by sieving. So how you are determining the particle size distribution by sieving grain size analysis and to determine the finest modulus, effective size and uniformity coefficient. So this test is performed to determine the percentage of different grain size contained within a soil. The mechanical or sieve analysis is performed to determine the distribution of the coarser, larger size particle. The distribution of different grain sizes affect the engineering properties of soil. Grain size analysis provides the grain size distribution and it is required in classifying the soil. So specification. This test is specified in IS 2720 Part 4 1985. Method of test for soil Part 4 grain size analysis. So what are the equipments required? CO sizes 4.75 mm, 4 mm, 2 mm, 1 mm, 500 micron, 250 micron, 150 micron, 25 micron, and 75 micron. It is IS 460 is used. The CO for soil test is 4.75 mm to 75 mm. Thermostatically controlled oven. Trays, sieve brushes, motor with a rubber covered pistol, etc. Mechanical sieve shaker, etc. So, which is why this test is carried out to determine the grain size. What is the size of your aggregate we are interested in? Whether it is a fine aggregate, whether it is a coarse aggregate. So, normally the aggregate passing through 4.75 MCU is termed as your fine aggregate. If it is a retainer, then it is called as coarse aggregate. So, which specification is IS 2720 Part 4 1985. The method of test for soil Part 4 grain size analysis. And what are the equipments required? Sieve of sizes 4.75, 4, 4.75, 4, 2, 1, 500 micron, 250, 125, 75. So that is IS 416 1960 is you. The sieve for soil test 4.7. So if you see it carefully, we are dividing by 2. If you remove this 4.75, you can start with 4. Exactly half is 2, 1, 500 micron, 250, 125, 75. So for this purpose, IS 460 1962 is used. Thermostatically controlled one is also used. Trays, sieve brushes, motor with a rubber covered pestle, etc. Mechanical sieve shaker, etc. Theory. The grain size analysis is widely used in the classification of soils. The grain size analysis is widely used in the classification of soils. The data obtained from grain size distribution curve is used in the design of filters for earth dams and to determine suitability of soil for road construction, airfield, etc. Information obtained from grain size analysis can be used to predict soil water movement, although permeability tests are generally used. So what we are trying to do, the grain size analysis is widely used in the classification of soil. The data obtained from grain size distribution curve is used in the design of filters for earth dams and to determine suitability of soil for road construction, airfield, etc. Information obtained from grain size analysis can be used to predict soil water movement, although permeability tests are generally used. See here, what is the purpose of conducting this test? The grain size analysis is widely used in the classification of soil. In order to classify the soil into different types, this analysis is carried out. The data obtained from the grain size is used in the design of filters of earth dams. If you're designing a filter of an earth dam, at that time also it is helpful and to determine suitability of soil for road construction, airfield, etc. Whether this type of soil is good for Making notes and that also can be identified or calculated using your COs. Information often from there can be used to predict soil water movement, although primarily tests are generally used. The method is applicable to dry soil passing through 4.7 CO, less than 10% passing through sulfur microphone MC. Percentage retained on NEC is equal to weight of soil retained divided by total weight into 100. Similarly, cumulative percentage retained on all courses is equal to sum of percentage retained on NEC. Percentage finer than NEC percentage retained equal to 100% minus cumulative. Precautions. What are the precautions you need to take while carrying out this and clean the sieve so that no soil particle is stuck in there while we put the sieve with the soil sample on the balance in a concentric position. Check the electric connection on the sieve shaker before conducting the test. No particle of soil sample shall be pushed through the sieve. Procedure. Take a representative sample of soil received from the field and dry it in the oven. Next, use a known mass of dried soil sample with all the grains properly separated out. The maximum mass of soil taken for analysis may not exceed 500 gram. First step is you have to take a representative sample of soil received from the field and dry it in the oven. Next is use a known mass of dried sample with all the grains properly separated out. The maximum of soil taken for analysis may not exceed 500 gram. Prepare a stack of sieves. Sieve the sieves one over the other with an ascending order. Sieves having larger openings and that is lower numbers are placed above the one with small opening that is smaller number. The very last sieve is 200 that is 75 mechanism. A pan is attached to the lowest 75 mechanism to collect the portion passing through 200 sieve and feed it to next to a mechanical shaker. Make sure sieves are clean. If many soil particles are stuck in the opening, try to poke them out using brush. The whole nest of sieve is given a horizontal shaking of for 10 minutes in sieve shaker till the soil retained is constable. Determine the mass of soil retained on each sieve indicating the collected in the pan below. So the test result include the test result of configuration given below. Serial number, ISCU, particle size in mm, mass retained, corrected mass, cumulative mass retained, cumulative percentage retained, percentage final. So cumulative mass retained in W grams. So graph size, grain size in mm versus percentage final. mm. Draw graph of log sieve size versus percentage final. The graph is known as grading curve, corresponding to 10%, 30%, and 60%. Final obtained diameters from the graph. These are colored D10, D30, D60. Using this obtain CC and CU, that is coefficient of curvature and coefficient of rotation, which further represent how well the soil is graded. That is whether the soil is well graded, gap graded, or poorly graded. That is graph 1 grain size in mm versus percentage final. Left side is what you can say percentage final. X-axis grain size mm. Pre-viva question. Define the grain size analysis and what is the cell size. Grain size analysis is nothing but analysis used for knowing the size of different grain. What is the uniformity coefficient? What is the why uniformity coefficient calculated in order to know how much particles are uniform? What is the most basic classification of soil? IS classification, BIS classification. What are the methods of soil gradation and grain size distribution? Different methods are there. How do you compute U10 by using CNS? Using graph, we calculate D10 How do you compute CC and CU? CC and CU is also calculated using your graph. What is poorly graded, graded and well graded soil? Poorly graded means the soils are not properly compacted. Gap graded means in between their voids are present. Finally, well graded means they are compact against coefficiently. Uniformly coefficient is given by CU, coefficient of corrosion is given by CC. Percentage of gravels, percentage of sand, percentage of silt. Verification validation. For the soil to be well graded, the value of coefficient of C has to be greater than 4 and CC should be in the range of 1 to 3. The higher the value of Cu, the larger of the rain particles. So if the value of Cu value is high, it indicates the soil mass condition different particle. Conclusion: the uniformity coefficient Cu is given by this formula coefficient of curve Cc. The value comes in the range of well soil. So does grain distribution affect the voice of the soil? No. Could the quality of soil enhanced by the grade of sand? No. If soil is uniformly graded towards ratio is high or low. Well graded aggregates require less cement or yes, less required. What is the practical saving with IS? It can be helpful for IS classification. So the next experiment is determination of liquid limit of fine soil. Super air is going on. We wait for 2 minutes. So the next experiment is determination of liquid limit of fine soil. So it is experiment number 8 to determine the liquid limit of soil by using Casagrande apparatus. So when water is added to a dry soil, it changes its state of consistency from hard to soft. So this is a natural phenomena. Soil is there. If it is hard, if you add water to it, it will it will change its state from hard to soft. We can define liquid limit as the minimum. So I'm sharing the screen. I hope it is visible to you. So where did we stop? We stopped with respect to determination of liquid limit of soil, liquid limit of soil by Cassegrain method. So when water is added to the dry soil, what happens? It changes its state of consistency from hard to soft. We can define liquid limit as the minimum water content at which the soil is still in liquid state but has a small shear strength against flow. So how we are defining liquid limit? Minimum water content at which the soil is still in liquid state but has a small shearing strength against flow. From test point of view, we can define liquid as the minimum water content at which a pad of soil cut by a groove of standard dimension will flow together for a distance of 12 mm, half inch under an impact of 25 kilos in the device. So specification, this test is done to determine the liquid limit of soil as per IS 2720 Part 5 1985. So after receiving the soil sample, it is dried in air or in oven, maintained at temperature of 60 degrees Celsius. It clots are then in soil sample, then it is broken with the help of wooden mallet. The soil passing through 425 microns sieve is used in this test. So what are the equipments required? A mechanical liquid limit apparatus, that is Cassegrain type with grooving tools. Next, evaporating dishes, wash bottle, etc. Balance accurate to 0.01 gram. Airtight container to determine water content. Oven to maintain temperature at 105 degrees Celsius to 110 degrees Celsius. Sieve 425 micron. Spatula, desiccator and other accessories. So what are the apparatus required in this liquid limit apparatus? A mechanical liquid limit apparatus, that is also known as Cassegrain type with grooving tools. Next is evaporating dish, wash bottle, etc. Evaporating dish are used, that is what works. Balance accurate to 0.01 gram. Airtight container to determine water content. Oven to maintain temperature at 105 degrees Celsius to 110 degrees Celsius. Next, sieve of 425 micron. Next, spatula. Next is desiccator and other accessories. So what is the theory part? Consistency of fine grained soils may be defined as the relative ease with which a soil can be remolded. Consistency limits may be categorized into three limits called Atterberg limit. So what are the three limits? Consistency limit, liquid limit, plastic limit, and shrinkage limit. So first is liquid limit. So how you are defining liquid limit? Liquid limit is the moisture content that defines where the soil changes from a plastic to viscous flow state. Other limits we discussed during corresponding experiment. So what are the precautions you need to take while carrying out this test? Soil used for liquid limit determination should not be over-dried prior to testing. Next, in liquid limit test, the groove should be closed by the flow of soil, not by the slippage between the soil and the cup. After mixing the water to the soil sample, sufficient time should be given to permeate the water throughout the soil mass. Wet soil taken in the container for moisture control should not be left open in the air. The container with soil sample should either be placed in desiccators or immediately be wet. After performing each test, the cup and grooving must be clean. The number of blows should be just enough to close the groove, and the number of blows should be between 10 and 40. So procedure, a representative sample of mass of about 120 gram passing through 425 micron ISC is taken for the test. So what we are trying to do? A representative sample of mass of about 120 gram passing through 425 micron ISC is taken for the test. Mix the soil in an evaporating dish with distilled water to form a uniform paste. Adjust the cup of the device so that the fall of the cup on the hard rubber base is 10 mm. Transfer the portion of the paste to the cup of liquid lemon ice. Allow some time for the soil to have uniform distribution of water. Level the soil topsoil so that maximum depth of soil is 12 mm. A channel of 100 mm wide at the top, 200 2 mm at the bottom, and remember is cut by the grooving tool. The grooving tool is held normal to the cup and the groove is cut through the sample along the symmetrical axis of the top. The handle of the device is turned at the rate of about 2 revolutions per second, and the number of blows necessary to close the groove may fall in the range of 5 to 40 blows. A plot of water content against the log of blows is made as shown in the figure. The water content 24 hours gives the liquid limit. Number of blows versus water content. Number of blows, weight of container is W1, weight of container plus wet soil is W2, weight of container plus dry soil is W3. So your water content will be W2 minus W3 divided by W3 minus W1. So the water content will be W1 plus W2 plus W3 plus W4 divided by 4. A semi-log plot of number of blows versus water content is done for the table. Water content at y-axis, number of blows on the x-axis. So what are the pre-viva questions? Define consistency of soil, how it is measured. Consistency of soil, just now I have explained you. Next is what is liquid limit of soil, minimum water content required to change the state of the soil from solid to liquid. What is the apparatus used from a liquid limit? Casagrande apparatus. Next, when a soil sample is given, what is the procedure for the liquid? Procedure just now I have said. From the graph, flow index is equal to IF minus W1 minus W2 divided by log of N2 by N1. And the liquid is calculated in terms of percentage. Verification or validation. If natural moisture content of soil is closer to liquid limit, the soil can be considered as soft. If the moisture content is less than the liquid limit, the soil is brittle and stiffer, and the point on the graph are often scattered. We need to draw the linear curve at the mean. Flow index indicates the rate at which the soil loses shearing resistance with an increase in the water content. So the soil type and liquid limit. Sand equivalent on silt is in between 30 to 40, clay is between 40 to 150. So what is the conclusion? As per the procedure, the experiment is carried out for 25 blow and the water content is dash percentage. So what are the post bio question? What is the purpose of computing the liquid limit of soil? So the main purpose of calculating the liquid limit of soil is to know how much amount of water is to be added to convert the state of the soil from solid to liquid. What is the organic matter in the soil? Will the liquid degrade? See, organic matter may be anything and it may affect the strength, liquid limit of the soil. It may decrease or either may increase. So the next experiment which we have to see is plastic limit of soil, which is also with respect to consistency limit only. Consistency limits are liquid limit, plastic limit, and shrinkage limit. So just now we have seen about liquid limit. In the next class, we will see about plastic limits. If you have any doubts and queries, you can just drop a message in the comment box, or you can email me at nadim@gmail.university, or even you can just call me at 8553171859 during evening hours. I hope it is understood to you. In the next class, we will see plastic limit.